So once more, I want to take a look at the graph of this r equals a over 1 plus e cos theta. Um, and again, I'm going to do it by looking at the graph of the denominator and then taking the reciprocal and then scaling it by a. In this case, though, I have e being bigger than 1. So with e bigger than 1, the amplitude of this cosine curve is bigger than the vertical shift. So when I look at the graph of that thing, right, I got an amplitude e cosine curve shifted up 1. So that's going to look, some cosine curve is going to look something like this. So there's 2 pi, here's pi. So it's going to go as high as 1 plus e and as low as 1 minus e here. With e being bigger than 1, 1 minus e is now negative. Now 1 is right in the middle of the high and the low point, so 1 is maybe right here. This would be at pi over 2, and right here would be at 3 pi over 2. Okay. That's where 0 got shifted up 1. Right? Now, the interesting thing here is that when we take the reciprocal of this thing, there's 2 spots. So in red here, I've got 2 spots where the denominator is turning into a 0. So there should be asymptotes here and here when I draw the graph of the reciprocal here. So I'm going to draw this thing. There's an asymptote right there, and there's an asymptote right here. Again, the reciprocal of, whoops, what just happened there? The reciprocal of 1 is going to be 1. So where that height is 1, this red graph is going to be at 1. Right? But anything less than 1 is going to give you a reciprocal that's bigger. So that's going to be headed up. Anything bigger than 1, so where the r values are bigger than 1 here. I never said that was theta. This is r. This is theta. This is r. Big values, when you put them in the denominator, give you small results. So you get something that looks like this. Same thing on the other side here, where that's a 1 right like that. When this is small, close to 0, the reciprocal is big. And then when the function is big, the reciprocal is small. So it does something like that. Now it doesn't come, this only gets up so high, so then the reciprocal of that is the height that I needed to end at, that height and this height. Right? Well, it's going to be the reciprocal of 1 plus e. Right? That's the height right there and there. Now, in this stretch in between here, in between where this was 0 and that was 0, the function is negative. R is negative here, so the reciprocals are also negative. There's this farthest away from 0 spot, and that's going to be the closest to 0 spot. So the reciprocal of 1 minus e is going to be something here. And then from there, this all gets closer to 0. So the reciprocal gets further away from 0, so that heads down there and down there. And then this would all repeat itself. This is just from 0 to 2 pi here. And then the whole thing would repeat itself, of course. Multiplying by a just scales things up. Let me do this in green like I've been doing. So with a, it just scales it, pushes everything further away from the axis here. It doesn't shift it, it scales it. So this thing here being negative, then you still have the negative times a, which is just further away. And I'm assuming a is bigger than 1 here. If a was less than 1, then it would have sucked it in towards the theta axis there. So now I want to actually draw the polar graph of this thing. So we'll grab this color again. I'm going to scoot down this time. Oh, and I've moved over a little bit. So now in the xy plane, I'm thinking of theta as an angle measured from the positive x-axis, and I'm thinking of r as a distance away from the origin. So, so now I'm looking at this green graph thinking, okay, how am I going to do this? So in the direction of 0, I'm out here, and then everything gets further and further away, and there's this spot here, which is apparently just before pi over 2. No, just after pi over 2. right? Because pi over 2 I was at 1. Pi over 2 I was at 1. So you come out to here. Well, this was at 1, so that one's at A. So at this spot I'm at A here. And then you run up against an asymptote. Now that asymptote is at some angle a little bit bigger than pi over 2. So I'm going to put an angle here. Actually, let me put it up about here. Where this curve is going to just head out parallel to that. That is, as I get closer and closer to that angle, I'm getting further and further away. It goes really far away, right? Then what happens on the other side of that asymptote? Well, on the other side of that asymptote, r becomes negative. So we're actually, let me scoot down a little bit more here. So we're looking at just past that direction. So I'm looking out here, but I'm going to be plotting behind me. So because r is negative, so I'm going to be plotting way back here somewhere. Whoops, way back here somewhere. And then as I keep turning, by the time I get to pi, this has come into its closest approach. But negative, sorry, I'm right here, negative. So this has come in something like this and hit right there. And then it starts going back out again until it approaches this other direction. Let's draw a line in here where these negative distances, I'm looking, you know, I'm looking off in this direction, but I'm plotting behind me back here, right? And then once I cross over that asymptote, so now I'm looking in this direction, I'm plotting in front of me again, because suddenly once I cross that asymptote, r is positive again. So I'm looking off in this direction, and I'm plotting off in this direction. And then it comes right back down into that right there. So the graph that I just drew started off here, headed out to infinity, came back in over here, got as close as it could be on the negative side. That was right there. Right there. No, right here. And then it head out to infinity again, but in the negative direction, because I'm actually looking over here. Cross over that asymptote, and you come back in like this. Okay. What does that look like? It looks like an hyperbola. And we'll show in the next video that indeed these are conic sections, and this is a hyperbola.